So VCE will be equal to VCEQ plus ICQ into RAC. See here, I am replacing RAC because in AC load, when you consider, you have to consider your load also. And when you consider the current, IC equal to ICQ plus VCEQ by RAC. So Ohm's law, V is equal to IR, right? V is equal to I into R. I is equal to V by R. See, all the suffix Q indicates your Q point. Okay, so you got the point C and D. So see the diagram. You got the point C and D. C is slightly above A and D is slightly below B. And join CD. And what one unique thing you will find, both these will intersect at the same Q point. Your DC load line and your AC load line will intersect at the same Q point. That is a speciality of your transistor. And that has to be checked also. So if the both the Q points are not, if the both the lines are not meeting in the same Q point, then the transistor has some issue. Okay, so first you find out the DC load line, draw the line. Then you find out the AC load line using the same procedure how you use for DC load line, except you have to replace RC by RAC, and RAC is going to be the parallel combination of RC and RL. So by joining C and D, you get your AC load line CD. And you can see that the AC load line will be more steep compared to your DC load line. So when you compare the steepness, AC will be more steep compared to your DC load line. You can see the angle, the slope of CD is larger compared to slope of AB, right? So the steepness of AC load line is very, very large when you compare with the DC load line. So when you don't apply any signal, it is going to refer to your DC conditions. Okay, so from the diagram, we have seen clearly that the intersection of both the load lines is going to be your operating point Q. So you might get problems in designing, drawing the AC and DC load in for a transistor. Only one equation you have to remember. What is that equation? This one equation. VCC equal to IC into RC plus VCE. This one equation, if you remember, you can solve any problem in load line. This is for DC load line. How the same equation will change for AC load line? What you should replace for AC load line? The same equation, what we should replace for AC load line? We have to replace what? We have to replace which parameter? Yes, RC by RAC, and RAC is going to be the parallel combination of RC and RL. If RL is not given, then your RAC and RC, everything is going to be same. Okay, so if our load resistance is not given, then your DC load and AC load will be same, because RAC is same as RL. If specifically a load resistance is given, then you will be having separate line for DC and AC load line, and you have to ensure that the intersecting point of the AC and DC load line should be the Q point of your transistor.